Hi everyone. So I'll talk about law of gravitation. Law of gravitation is a universal law which tells us that not only on Earth but everywhere in outer space, in any other planet, between any other two planets, between all of the galaxies, everything, we have this gravitational force between objects that obviously are having some mass. So all objects with mass of m, they attract one another if they are r meters away from each other. The force of gravitation, this attractive force, is given by g, a constant, and I'll tell you what that number is. It's constant for any two masses. One mass times the other mass divided by the distance between them, but squared. Okay, so this tells us how strongly two masses of m1 and m2 attract each other. So the thing that you need to bear in mind is that this constant is a very, very small constant of 6.67 times 10 to negative 11 newtons meters squared over meters squared over kilograms squared. So that's this number is very, very small. The fact that we don't see, for example, these two markers attract each other, we don't see these two guys getting together, let's say, is due to the fact that this g is a very, very small number. So these masses, they have to be very, very big in order to overcome this negative 11 when we multiply things. So suppose I'm just doing this, I'm measuring or calculating gravitational force between two markers of, let's say 200 grams or something. So this is the g, that's the constant that's everywhere, and it's just a constant number regardless of what our masses are. And then one of the masses is 200 kilograms, 200 grams, that's 0.2 kilograms. The other is as well, and they're, let's say, 1 meter, like 3 feet apart, like about 1 meter apart, so 1 meter squared. And then my force would be 6.67 times 10 to negative 13 times 4 over 1. So this is going to be around 26, I guess, something around that number, times 10 to negative 13 newtons. So this number is ridiculously small. So 10 to negative 13 is like a very, very small number. Hence, we don't see these. It's not visible that these two guys are attracting one another. But what happens when some massive object like Earth is in play? So if Earth comes into play, then because of its humongous mass, then what happens is that any other object with even like very little mass, this mass of Earth that's multiplied in this formula by the other mass is going to overcome the smallness of g. Hence, it gives rise to some big attractive force, as we can see right now. So even if the marker is like 0.2 kilograms, then because mass of Earth is pretty big, so mass of Earth is about 5.98 times 10 to 24 kilograms. That's big. So when this guy gets multiplied by negative 11, it essentially overcomes that smallness of minus 11. Hence, it gives rise to a very big force, not a very big force, but visible force, let's say. Hence, we actually see the gravitation, like this pulling force of gravity from objects to Earth. So this is essentially what law of gravitation is about. And the other thing I would like everyone to appreciate is the fact that we always said, well, acceleration due to gravity is, 10 meters per second squared, or if you want to be more accurate on that, it's like 9.8 meters per second squared, but we round it up usually to 10 meters per second squared. Let's see how we can derive that. So here is Newton's apple, that gets attracted by Earth. So, and let's just write law of gravitation between Newton's apple and Earth. So G is a constant number of 6.67 times 10 to negative 11. Mass of Earth, I just said, it is 5.98 times 10 to 24. And let's say the apple is about about a half a pound. So it's roughly 0.2 kilograms. And then, so then the distance between this and Earth is essentially between this and the center of Earth. So the center of Earth to this apple is radius of Earth plus this little 1 meter thing. The radius of Earth is big enough to swallow this little number. So the radius of Earth, if we include just that would be more than enough. And this is the radius of Earth is 6.37 times 10 to 6 meters squared. Sorry, time to 6, but we have to square it right here. So that's that. And then when we calculate everything, if we punch, so this is a constant number, the G. Mass of Earth, the first one, is also a constant number. Radius of Earth is also a constant number that's going to be squared. And I want everyone who watches this video, please calculate this in your calculator or by hand or whatever fashion you like. And then you'll see that this gives you 9.8 meters per second squared. Hence, F is 9.8, or the one that we always talk about, like 10, roughly 10 meters per second squared, times the mass of the Newton's apple. So that's why we call this 9.8. We give it a symbol because it's also a constant. We give it a little g, and that's why this is the mass of the Newton's apple. This is the g. And we always write it as m times g, right? So this is essentially why we say weight of everything, if we live on Earth, is m times g gravity of Earth, which is literally roughly 10 meters per second squared. So this is the reason behind it. So we can actually get it from the law of gravitation if we work out the numbers and all that sort of stuff. In the next video, I'll talk about the two different problems that can both of them, it's essentially law of gravitation, and I'll tell you how to solve those problems. Bye now.